This is Anil Reddy, Assistant Professor of Mathematics, MLR Institute of Technology, Hyderabad. So today I am going to explain about Taylor series method. So this method is mainly concentrated on numerical solution of ordinary differential equations. To find numerical solution of ordinary differential equation, we use the following methods: Taylor series method, Euler's method, modified Euler's method, and RK method. So now today we'll discuss Taylor series method, how to find the numerical solution of ordinary differential equation. Taylor series method is now consider the first order differential equation, that is dy by dx is equal to f of x comma y with the initial condition y of x naught is equal to y naught. Now y of x can be expanded as y of x can be expanded about the point x naught using Taylor series method. In powers of x minus x naught, so that is y of x can be written as y of x is equal to y of x naught plus x minus x naught. So this can be expanded as y of x naught plus x minus x naught by 1 factorial into y naught dash of x naught plus x minus x naught whole square by 2 factorial into y double dash of x naught plus x minus x naught whole cube by 3 factorial into y triple dash of x naught and so on. So this is y of x. So or we can write this as y1 is equal to, that is y of x1, y of x naught plus x minus x naught. So let we take x is equal to x1, that is equal to x naught plus h, interval difference. So we write x minus x naught is equal to h. So here the x minus x naught is the interval difference. So we replace this x minus x naught as h by 1 factorial into y naught dash of x naught plus h square by 2 factorial into y double dash of x naught plus h cube by 3 factorial into y triple dash of x naught and so on. So this is y1 is equal to, we can write y of x naught is nothing but y naught. So y naught plus h by 1 factorial into y dash of y dash naught plus, because y of x naught is equal to y naught, so we are replacing y dash of x naught with y naught dash or y dash naught plus h square by 2 factorial y naught double dash plus h cube by 3 factorial into y naught triple dash and so on. So similarly we can write y2 is equal to y1 plus h by 1 factorial into y1 dash plus h square by 2 factorial into y1 double dash plus h cube by 3 factorial into y1 triple dash and so on. In this way we can write in general we can write yn plus 1 is equal to yn plus h by 1 factorial into yn dash plus h square by 2 factorial into yn double dash plus h cube by 3 factorial into yn triple dash and so on. So this is called generalized Taylor series formula. So using this formula we can find the numerical solution of ordinary differential equations. So here, so one example is there, so we'll discuss this example. Solve dy by dx is equal to x plus y given that y of 1 is equal to 0. So with the initial condition is given y of 1 is equal to 0. So this is y naught value and this is x naught value. We have to find y of 1.1 by using Taylor series method. So given that y dash is equal to x plus y and initial condition is y of 1 is equal to 0. So y of 1 is equal to 0, we can write it as x naught value is 1 and y naught value is 0. Now we have to find y of 1.1. So you will take this as equation number 1. Now differentiating with respect to x, differentiate with respect to x of equation 1. So we get y double dash is equal to, so this is y divided by dx, y dash is equal to x plus y and y double dash is equal to x is 1 plus this is y dash. So this, let us take equation number 2. Now again differentiating with respect to x, we get y triple dash is equal to 0 plus y double dash. This is equation number 3. Now we'll do one more time. So y fourth order is equal to y third order. So that is equation number 4. Now so we have to find y of 1.1. Y of 1.1. So that is y of 1.1 means x1 is 1.1 and we already know that x naught is equal to 0, x naught is 1 and interval difference we write h is equal to x1 minus x naught, that is 1.1 minus 1, this is 0.1. So interval difference h is 0.1. Now by using Taylor series method, so we write the formula as y1 is equal to y of x1. So that is y of 1.1 is equal to y naught plus h by 1 factorial into y naught dash plus h square by 2 factorial into y naught double dash plus h cube by 3 factorial into y naught triple dash plus h power 4 by 4 factorial into y naught fourth order and so on. Okay, right. Now we have to find this y naught dash, y naught double dash, y naught triple dash and so on. So we take this as equation number 5. Okay, now we will find the values of this y naught. We already know that what is y naught. So y naught is equal to 0. Y naught value is 0. Now we have to find y naught dash. So y naught dash is equal to, what is y dash? Y dash is equal to x plus y. From the equation 1, y dash is equal to x plus y. So we can write y naught dash is equal to x naught plus y naught. So here already we know the value of y naught. So y naught dash is equal to x naught value is 1. So 1 plus 0. So this is 1. So y naught dash is 1. And similarly we can find y naught double dash. So y naught double dash is equal to, so using equation 2 we can write y naught double dash as 1 plus y naught dash. So y naught double dash is equal to 1 plus, what is y naught dash? 1. So 1 plus 1, this is 2. Y naught double dash is equal to 2. And similarly we can find y naught triple dash. So y naught triple dash is equal to, so from equation 3 we can write this as y naught double dash, but already we know that y naught double dash is equal to 2. So y naught triple dash is equal to 2, and y naught fourth order is equal to, from equation 4 we can write y naught triple dash and this value is 2. So now we substitute these y naught dash, y naught double dash, y naught triple dash and y naught fourth order values in equation, this is equation 5. Okay, we substitute here, then we'll get y of 1.1. So that is y1 is equal to y of 1.1. So we are finding the value of y of 1.1. This is equal to y naught plus, what is y naught value? Y naught value is 0 plus h, interval difference is 0.1 by 1 factorial into y naught dash. So y naught dash value is 1. So this is 1 plus h 0.1 whole square, h square by 2 factorial into y naught double dash, that is 2. Y naught double dash value is 2. So 2 plus 0.1 h cube, 0.1 whole cube by 3 factorial into y naught triple dash is also 2 plus h power 4, 0.1 whole power 4 by 4 factorial into y naught fourth order value is also 2. So and so on. So we can write this value as, so by doing the calculation of this, so we'll get y of 1.1 as 0.1103. This is an approximate value, not exact value. So by using numerical methods we can get the approximate value. So by analytical methods we get the exact solution or exact value. So here we get the approximate value as 0.1103. So in today's session we have discussed about Taylor series method of finding the numerical solution of ordinary differential equations. So in the next session we will discuss Euler's and modified Euler's method. So these are also finding the numerical solution of ordinary differential equations with the following methods. Okay, thank you.